right, so we're going to be looking at graphing linear inequalities in two variables in this video. So this is the second page of the guided notes for that section. So the method we used in the overview is just summarized here. So the first thing we're going to do is set up the related equation. So that would be graphing y equals 3x minus 1 on question number 5. All right, then we're going to graph that. So when you graph that, you can use the slope. If you like to graph that way, the slope is 3 and the b value is -1. Remember, you need to think rise over run. So if you don't have a fraction, put a 1 underneath the slope value. So you can begin at -1, and then I'm going to go, since 3 is positive, I'm going to go up 3 units and to the right 1. I like to do that a couple times. I'm going to go down 3 and to the left to get a good collection of points. Now, when I graph the line, I have to make it where either the points on the line are part of the solution or they're not, and that depends on the or equal to right there. So since it does have the or equal to, when I graph this, the line is going to be solid. All right, so that's saying that the boundary, the points on this boundary are part of the solution. All right, now at this point, I have to decide which side to shade. So what we're going to do is the next part where we're going to look at picking a point that's not on the line. So any point as long as it's not on the line. So I might pick a point like this. All right, so that ordered pair is the point 2, 1. Okay, so I'm going to take my inequality. So this is step 3. I'm going to take my inequality now. I'm going to put 1 in for y and 2 in for the x, and I'm going to see if that is a true statement or not. Is 1 bigger than 6 minus 1, which is 5? Is 1 bigger than 5? And the answer is no. So that means this right here is not a solution. So that is not a solution. It doesn't work. So that means I wouldn't want to shade that side of the line, because the shading indicates the points that are in the solution. So I'm going to shade over here. Okay. And I'm shading right on up to that line. I'm not stopping at the y-axis. The line I graphed is the boundary. Okay. All right, so problem number 6, I got to do the same thing. This one's also in slope-intercept form, so a good way to graph that is just using the slope and the b value. So remember, rise over run. So that's the rise. So that's up 2. That's the run. So that's right 3. But the b value is where you begin. So the b value is -2. That's always the y-intercept. Then I'm going to go up 2 and over 3. Of course, you can just find ordered pairs and plot those ordered pairs. I could go down 2 and to the left 3 to get another point on the line. Now, see how this one does not have the or equal to on it? So that's going to be dashed. That indicates, that's like an open circle in a way. It indicates that the points on the line are not part of the solution set. Okay, so it's just dashed. But that forms the boundary between the points that work and the points that don't work. Okay. So now what I'm going to do is test a point. So I'm going to pick a point that's not on the line. So I'm going to pick that point 2, 1. I just like to pick something with small positive coordinates. Okay, and so I'm going to test that. So I'm going to test that point. It can be any point. It just needs to not be on the line. And I'm going to put that point in the inequality. Ooh, I wish I had picked a different point. I'm going to change that. See how the denominator is 3? Sure would be easier if I picked a point that had a 3 or a 6 in that first spot. So I'm going to go over and move to 3, 1. So let me test that. So if I put a 1 in for the y, let me do that in red. So I'm going to put a 1 in for y, and I'm going to put in a 3 for the x, and I'm just testing whether it makes the inequality true or not. So if I put the 3 in, I get 1 greater than 3 times 2/3 would be 2 minus 2. I'm asking whether that's true. Okay. So I get 1 greater than 0. 1 is greater than 0. The answer is yes. So that means when I shade, I have to shade the side. This is a solution. So this works. This works right here. So that means I have to shade that side. Okay. So that whole picture is the answer to the question. All of the ordered pairs in that shaded region work, and it's all the way up to this boundary line. The points on the line don't work. That's why it's dashed. And then, of course, the points that you see below the line aren't part of the shaded region. Okay. Now, both of those times I just happened, or no, on one of these, the point I picked worked, so I shaded the side where that point was. On the other one, the point I happened to pick, was not a solution, but that still gave me the information I needed. It just meant I needed to shade the other side. So it's pretty logical if you'll take time to think about it. Okay, let's do 2 more of these. All right, so now I'm graphing the line 4x minus y is less than or equal to 5. So notice how it's got the or equal to. That tells me when I do draw the line, it's going to be solid. When I graph 4x minus y equals 5, which is what I'm going to do first, I could solve for the y variable or just find ordered pairs that make this true. So like I might put a 0 in for x. And if you can do it in your head, that's fine. If not, you just plug the 0 in to the equation and you work it out. So see how that would mean that negative y has to be 5. There's an understood 1 in front of that y. So just divide by negative 1, and you find out y would have to be negative 5. Okay. If I put a 1 in for x, it'd be 4 times 1 minus y that would equal 5. 4 minus y would equal 5. So when I subtract 4, I'd have negative y equaling 1, which would mean y itself would have to be negative 1. Okay. All right, I didn't want to use a 0 for the y because 4 doesn't go into 5 evenly, so it doesn't work out real nice. So that's why I didn't do that. If I put a 2 in for x, I can do that one in my head. Do you see how that first term would be 8? So I know I'd have to have minus 3. So the y value would need to be 3. So 0, negative 5, 1, negative 1, 2, 3 should all be on that line. So I'm going to draw a line connecting those, and I've already determined it should be solid. The points on the line work. So you need a solid line indicating that. All right, now I'm going to pick a point not on the line. Might try this point. It's not on the line. It's easy to plug in. So let's test if 0, 0 works. So is 0, 0 a solution? So I'm going to put in 0 for x, 0 for y, and see if it works in the inequality. So is 0 less than 5? Yes, it is. So that means that point I plugged in, that means that 0, 0 is a solution. So I need to shade the side where 0, 0 is located. You see the concept? It's kind of a 2-step process. You graph the line, which is the boundary between the points that work and the points that don't. Then you test a point that's on either side to see where the solutions are located. Okay? So the first step would be to graph 2x equals negative 6. We're in the context, even though you only see one variable, we're in the context of equations in 2 variables. So you should think of that as the equation that's just telling you that all the x's are negative 3 no matter what. So I'm always going to go to the left 3 no matter what. So like 3, 0, 3, 1, 3, negative 3, 0, negative 3, 1, negative 3, negative 2. I'm always going to be over here no matter what. So it's a vertical line, isn't it? Ooh, I almost connected it. I have to check. Should I dash it or make it solid? Okay, looking at that inequality, I see it should be dashed. So I'm going to make it dashed. Okay. And then the last thing I'm going to do is decide which side to shade. Now you probably don't really have to use a test point for this, because isn't that right there 2x less than negative 6? If I divided by 2, it's a positive number. It wouldn't change the inequality. Wouldn't I have x less than negative 3? If I need my x's to be less than negative 3, you probably don't need to use a test point. Can't you just see that it would be everything over here to the left side? Okay. Now be careful. If you had to divide by a negative, that inequality would have to get flipped. Okay. All right, so those are 4 questions just on graphing a single inequality in 2 variables.